Good day everyone, my name is John Ecarma from 10 Arellano, and I am here to discuss the principles of a light dimmer. Let's first talk about what is a light dimmer and how it operates. Light dimmers are electronic devices connected to a light fixture which is then used to lower the brightness of a light. Light dimmers operate by changing the voltage waveform applied to the lamp. It is then possible to lower the intensity of the output of the light. Light dimmers was first discovered in the year 1959. It was invented by a guy named Joel S. Spira. Spira is also the founder of the Lutron Electronics Company in 1961. Spira's light dimmer was based on a diode and a tap autotransformer which saves energy and allows it to be installed in a standard electrical wall box. I'll show you its first electrical light dimmer and its inside components right here. Now to its principles. Light dimmers has three principles. In order to dim the intensity of a light bulb, the flow of current is reduced, which corresponds to regulation of the brightness. The three principles of the light dimmer can be employed for this: voltage divider, leading edge phase control, and trailing edge phase control. The first principle, the voltage divider. The voltage divider is not used because of its energetic inefficiency, hence the voltage for the light generation is divided by an adjustable pre-resistor. The proportion of the unused power to generate the light is dissipated by the resistor and converted into heat energy. Second and third principle, the leading edge phase control and the trailing edge phase control. Phase control dimmers work considerably more efficient, since in this case the current is switched on and off by means of electronic circuits. The light bulb is switched at a frequency that is not discernible at the eye. Since the flow of current is interrupted during the dead time, the power dissipation is considerably reduced in comparison with the voltage driver. The ratio of the switch off time determines in both principles. One is the flow of current and the other is the quantity of emitted light. The basis of both principles is the sine waves of the mains voltage. At a frequency of 50 Hz, the voltage changes its polarity 100 times per second. It therefore also reaches the zero crossing point, which there is freedom from both current and voltage for a brief moment 100 times per second. Electronic phase dimmers control the effect produced by the light source by only letting the current flow over a certain section of the alternating voltage half waves. In the case of 230 volts general purpose lamps, the operating mode of the dimmer is unimportant because of the purely ohmic load. Type of leading edge phase control, inductive loads. Low voltage halogen lamps with conventional inductive transformers are controlled by thyristor dimmers based on leading edge phase control. In the leading edge phase control technique, the switch on point of the switch is changed in relation of the mains voltage half wave. The thyristor hereby becomes conductive at a controllable point within the voltage half waves. The flow of current is automatically interrupted at the next zero crossing of the sine half wave. This ensures that no inductive voltage peak occurs when switching off. I'll show you a picture of changing of switch on point with leading edge phase control right here. Type of trailing edge phase control, capacitive and ohmic loads. Trailing edge phase control is used with electronic low voltage transformers. In the trailing edge phase control technique, the switch off point of the switch is changed in relation to the mains voltage half wave. The current begins to flow exactly at the zero crossing of the voltage wave. The transistor dimmer terminates the flow of current at a controllable point within the half wave. Advantages of the circuit. The flow of current can be interrupted at any time. Very accurate control is possible and the flow of current is also interrupted immediately in the case of an overload or a short circuit. The generation of current peaks on input capacitors on the EBs is avoided, since the flat rise of the sine wave is used in order to charge the capacitor. The voltage required for the load is approached so. This accurate regulation protects the load. Trailing edge phase control dimmers are provided with a current limiter function, which reduces the output voltage in the case of overload. Furthermore, trailing edge phase control generates very little electromagnetic interference. Unfortunately, the types of switches used are very sensitive and are destroyed even by brief overloading. As prevention, therefore, complex protective circuits are integrated. 230 volts general purpose lamps, ohmic loads, and lamps with EVs can be used as loads. Here are the picture of change of switch point with trailing edge phase control right here. That's all. Thank you for listening.